part 3 of section 1.7. We're solving a less than problem. Right here, I have the absolute value of something that's fairly complicated is less than or equal to 20. But the absolute value is alone, so I can go ahead and rewrite this as negative 20 less than or equal to 3 times x minus 1 plus 2, just drop the absolute values, is less than or equal to 20. Okay, so I want to get x alone in the middle, so right here I'm going to distribute that 3. Negative 20 is less than or equal to 3x minus 3 plus 2 is less than or equal to 20. So this is negative 20 is less than or equal to 3x minus 1 is less than or equal to 20. All right, so let's add 1 to all three sides. And I get negative 19 is less than or equal to 3x is less than or equal to 21. And now divide everything by a positive 3. And I get negative 19 thirds, that doesn't simplify, is less than or equal to x is less than or equal to 7. Okay. These are going to have brackets. So I have negative 19 thirds here, and I have 7 here. Shade between. And then use this for your interval notation, which would be bracket negative 19 thirds, comma 7, close bracket. Okay. So let's do negative 3 times the absolute value of x plus 7 is greater than or equal to negative 27. I have this negative 3 in front here, and I really need this absolute value by itself. So I'm going to divide both sides by a negative 3 before I split this up. And because I'm dividing by a negative, I have to flip this sign around, which is good because if I don't get to flip the sign around, then I don't have a less than problem. And we haven't talked about how to do greater than problems yet. So this gives me absolute value of x plus 7 is less than or equal to, that's going to be a 9. So now that I have the absolute value alone, less than or equal to a number, I can rewrite this as negative 9 is less than or equal to x plus 7 is less than or equal to 9. Now let's get the x alone, so we subtract 7 from everything. And we get negative 16 is less than or equal to x is less than or equal to 2. These have equal to's, so these have brackets. Negative 16 and positive 2. Shade between. And then use this to get your interval notation, which is negative 16, comma 2, both within brackets. Okay, so let's go on and talk about the greater than problem. So again, we're going to get the absolute value alone. And again, we're going to use the same sign, either a greater than or equal to. So whether it has an equal to or not, that's what we're going to do it. We're going to rewrite this using 2 inequalities. We cannot write this as a 3-sided inequality. It does not work, okay? So basically what we do is we want the absolute value alone, either greater than or equal to k. And then as long as our k value is greater than or equal to 0, because remember absolute values cannot be smaller than 0, then our x, drop the absolute value, is greater than k, or drop the absolute value, flip the sign around, and change it to a negative. Okay? To create the second one, drop the absolute value, change the direction of the inequality, and change the sign of the constant. This time our graph will be unbounded, and basically our graphs are going to shoot off in 2 directions, and we will not be able to draw a circle around the entire graphed region. All right, so let's look at a simple example. Okay, I have the absolute value of x is greater than 5. Compare this to the problem we worked earlier. It looks basically the same, but here the absolute value is smaller than 5. Here it needs to be bigger than 5. All right, so our absolute value is alone already. So I write it first without the absolute value, basically as it is. Or, and this correlates with union, okay, or drop the absolute value, change the direction of the sign, and make it a negative. Okay, the numbers I need to see on my graph, and they're both going to have parentheses, is I need a -5 and I need a 5. Okay, now the values I'm looking for are either bigger than 5, and if they are bigger than 5, then they go off in this direction, and it has parentheses. Less than -5, so smaller than -5, that's going to be in this direction, and parentheses here. Notice our graph shoots off in 2 directions, and compare this graph to this one. Here we had the same 2 values. We had parentheses on both of them, but we were shading between them. We were looking for numbers that are between -5 and 5. Here we are looking for numbers that are outside -5 and 5, and we end up with an unbounded graph. Now, because we have 2 distinct regions, we have to write 2 distinct interval notations. You want to start with the left one and then go to the right one. Remember, it's your left boundary, right boundary. This goes off to -infinity, and negative infinities always get parentheses, and it goes up to -5, also with parentheses. Or you need to put this union sign in here. Now, the same thing here from 5 with parentheses, and this goes up off the graph to the right, so it goes to infinity. Technically, this is the same thing as this. Technically, they're the same. You can switch the order of the 2 interval notations, but you cannot switch the order inside the interval notation. Now, nobody ever writes it this way because it just makes more sense to most people to have the infinities on the outside, and it makes more sense to describe the left-hand region than the right-hand region. So you're generally not going to see this, even though technically it's okay. All right, so let's do x plus 3 is greater than or equal to 4. So again, we have the absolute value by itself, so we drop the absolute value completely, or we rewrite it without the absolute value, flip the sign around, so now it's less than or equal to, and instead of a +4, you write a -4. Now, this time I have things to solve. So here I'm going to subtract 3 from both sides, and I get x is greater than or equal to 1. Here, if I subtract 3 from both sides, I get x is less than or equal to -7. Okay, these have equal to's, so they are going to have brackets. And so I need a 1, and I need a -7, sorry, and I need a 1. Now I'm looking for numbers that are larger than 1, and numbers larger than 1 are off to the right. And here I'm looking for numbers smaller than -7, and those smaller numbers are off to the left. Okay. Describe the left-hand boundary. So -infinity up to -7, parentheses here, bracket here, union, bracket 1, comma, and this goes off to infinity. And that would be your solution. Now here we had the absolute value of x plus 3 is greater than or equal to 4. We also did the absolute value of x plus 3 less than or equal to 4. Here we had a bounded region between -7 and 1, so we got these same 2 values as we did here. It's just when it's less than, it's bounded and between, and when it's greater than, it's outside. All right, and this last problem is very similar to the last less than problem we worked. We need to get the absolute value alone, which means we need to divide both sides by a -2. And when I divide by a -2, I don't know why I put that there. I have to flip that sign around. So I get the absolute value of 5 minus x. Make sure your absolute values are significantly bigger than your other numbers, or you're likely to pick them up as a 1. And this is greater than +3. Okay, so now we write 5 minus x is greater than 3, or 5 minus x is less than -3. All right, so here I'm going to subtract 5 from both sides, and I get -x is greater than -2. Now, technically here I need to divide both sides by a -1, and since I'm dividing by a negative, I have to flip that sign around. So again, I'm flipping that sign, and I get x is now less than 2. Okay, here, subtract 5 from both sides. I get -x is less than -8. Divide both sides by a -1. And again, flip that sign around. And I get x is greater than 8. So the numbers I need are 2 and 8. These are both going to have parentheses. I'm looking for numbers smaller than 2, so these are to the left with parentheses here. And the 8 will have parentheses, and I'm looking for numbers that are bigger, so I shade off to the right with those. Now for interval notation, this is -infinity up to 2, union 8 to infinity. And that's our solution.